Hi, my name is Mariano Zeron, and in this video I'm going to show you how to extend the dimensionality of a MoCaX object. We call this operation extrusion. So as an example, let's create a MoCaX object for a one-dimensional function. In this case is the Black-Scholes pricing function. So as we already know, we can build this object very easily. So this is where it's built. We print it just to check what is it that we have. The final object that we have here has one dimension. The variable goes between 50 and 150. And that's basically all the information that we need. We also passed a derivative order of 1, but that's not going to be relevant in this particular case. What we're interested in seeing how to do is extend the dimensionality of this object. One situation where this could be useful is when you want to add two MoCaX objects, they have to be of the same dimensionality. So let's say that you've got another MoCaX object of dimension 2, and you would like to be able to add it to this object, but this one has just dimension 1. But what you do is extend it by one dimension. And the way that you're going to extend it is by simply repeating this function, the one that you already have in one dimension, along the other dimensionality. So, and the way that you do it is by calling a method of the MoCaX class called Extrude. If we go to the documentation, you can find it here. Extrude is within the MoCaX class. And what it says is that you have to pass a single parameter, which is the extrusion parameter, which is a set of pairs, each with the index of the dimension to extrude and the domain of such dimension. So let's go back to the code. What is it that we then need to pass? In our case, we're going to extend the second dimension, because we started with one dimensionality only, that is indexed by 0. Bear in mind that pretty much everything in Python is indexed from 0 onward. So the index 0 corresponds to the first variable, or the first dimension of our domain. So the second variable, which is the one that we want to extend, corresponds to index 1. So the extrusion parameter in this case would consist of 1, comma, and then the domain of that variable that you want to extend it to. And let's say that we extend it to 30, 90, just for argument's sake. So we've got that parameter. We pass it to the method extrude, and that returns an object that we called extruded MoCaX object. And if we print it, we see that we have an object that now has two dimensions and has the domain 50 to 150 for the first variable, which is the domain that it originally had. And then the second variable goes between 30 and 90, which is where the extrusion took place. Now, what happens, or what is it that we obtain in the end? In the end, we have an extruded object that now you can evaluate anywhere in the two-dimensional domain. And the original object, which is the one that we used in order to build the higher dimensional objects, that you can only evaluate in the first variable. Now, one property that this has, given the way that we extrude or that we extend the dimensionality of the objects, is that it doesn't really matter where you evaluate it on the second variable, it will always give you the same result. So for example, if you want to evaluate it at the value 100 in its first dimension, the second one is immaterial. You can evaluate it at 40, you can evaluate it at 50, as long as you're evaluating it within the allowed domain, which is the one that you specified at the time of extrusion, you always give the same result. So let's run the extruded MoCaX object evaluated at 100, 40, and then compare it to the MoCaX object, which is the original one, evaluated at 100. And that should give the same results. And indeed, that's what we obtain. And that would have happened independently of which value you choose for the second variable. So essentially, what we have here is a way of extending the dimensionality of the object, but of course, given that we don't have any further information from any function where we originally built the MoCaX object, the way that we do it is just naturally by repeating or naturally extending what we originally had. And this operation is essentially used only when you want to add between different MoCaX objects that have different dimensionality. That's essentially it. So it's kind of the opposite operation that we have from slicing, where we started with a high dimensional MoCaX object, and then when we went down to a lower dimensional object. So this is how we extrude objects. It's very simple and straightforward. Thank you very much. I'll see you in another video.